Imagine a world where you can zoom in close enough to read a newspaper from space, or peer through darkness and clouds to see what is happening on Earth. This is not science fiction, it is the reality of spy satellites. Meet the silent predator orbiting Earth at 17,500 miles per hour, capable of peering into your backyard from space. But how exactly do these satellites work? How powerful are these satellites? Can they really see a pin drop from space? Which countries are in this exclusive club of spy satellite operators? And could they ever be used to fire nuclear weapons from space? Let us embark on a thrilling journey into the world of spy satellites, also known as reconnaissance satellites. Stay till the end for some classified information about the modern spy satellites. At the heart of every spy satellite lies a sophisticated imaging system. Unlike your average camera phone, these satellites use high-resolution optics and powerful sensors to capture incredibly detailed photographs of Earth. We are talking about resolutions sharp enough to read a license plate from hundreds of kilometers away in the space. But visible light is not the only trick up their sleeve. Many spy satellites utilize infrared and radar technology to see through darkness, clouds, and even camouflage, making them effective around the clock and in all weather conditions. As the satellite orbits, it continuously captures images and transmits them electronically to strategically placed receiving stations across the globe. These stations then decipher the data and deliver it to intelligence agencies for analysis. It is a constant stream of information, providing real-time updates on troop movements, military exercises, and even potential threats. The first generation of spy satellites, such as the American Corona and Zenit, took photographs and then ejected canisters of photographic film which would descend back down into Earth's atmosphere. These capsules were retrieved in mid-air as they floated down on parachutes. However, modern spy satellites have digital imaging systems and download the images via encrypted radio links. They can achieve panchromatic, black and white, resolutions of around 10 centimeters, which means they can distinguish objects as small as 10 centimeters apart. Some advanced systems can even achieve multispectral imagery, capturing data from various parts of the electromagnetic spectrum, allowing analysts to identify materials and objects based on their unique spectral signatures. But spy satellites go beyond just high-powered cameras. Some are equipped with powerful electronic eavesdropping tools, known as signals intelligence systems. These can intercept and analyze radio waves, phone calls, and other electronic transmissions, providing valuable insights into military operations and diplomatic communications. This means they can hoover up hundreds of thousands of cell phone calls or scour the dark web for terrorist activity. But who are the sky spies? The world of spy satellites is a closely guarded secret, but a handful of countries are known to possess this capability. The United States leads the pack with its National Reconnaissance Office, NRO, operating a vast fleet of advanced reconnaissance satellites. It has launched 7 Orion satellites so far, with NRO-44 being one of the biggest. Russia, China, France, India, and Israel are also known to have operational spy satellite programs. Each of these nations has developed its own unique fleet of spy satellites, tailored to their specific needs and strategic interests. But what if these satellites could do more than just observe? What if they could carry nuclear weapons? Recent news reports indicate that Russia may be developing a nuclear space weapon. Good news is that international treaties like the Outer Space Treaty of 1967 prohibit the stationing of weapons of mass destruction in space. However, the bad news? There is a loophole. The treaty does not explicitly ban the development or testing of space-based weaponry. So, Russia can go ahead placing nuclear weapon in space in the name of testing and no law can stop it. Imagine a satellite capable of launching a devastating nuclear strike from orbit, a chilling thought, to be sure. However, the technical hurdles for such a weapon are immense. Building a nuclear weapon that can withstand the harsh environment of space is no small feat. Furthermore, launching such a weapon would be a clear act of aggression, likely triggering a global response. The potential consequences far outweigh any perceived benefits. But the story does not end there. The next frontier in space warfare might not involve nuclear bombs, but rather cyber attacks. Satellites are incredibly reliant on software and communication systems, making them vulnerable to hacking. A successful cyber attack could blind a satellite, disrupt its operations, or even redirect its data feed, potentially creating a major intelligence blackout. Several countries, including the US, China, Russia, and India, have been developing anti-satellite (ASAT) weapons designed to cripple or destroy other nations' satellites. These ASATs can take various forms, from kinetic kill vehicles, basically high-speed missiles, to electronic warfare systems that can disable a satellite's functions. Another game which is being played in the sky is of detecting spy satellites. Spy satellites use stealth technology and other methods such as painting the satellite with a special black paint made of graphene which allows the satellite to blend into the sky at night, making it less visible to ground-based observers. Additionally, satellites can also hide behind space debris to avoid detection. However, these methods are not foolproof. Advanced radar systems and other detection technologies continue to improve, potentially making it harder for spy satellites to stay hidden. As the space above us becomes increasingly crowded, the game of hide and seek between spy satellites and those trying to spot them becomes ever more complex and intriguing. So, there you have it. A glimpse into the secretive world of spy satellites and the potential for a new kind of space warfare. But remember, this is just the tip of the iceberg. As technology continues to advance, spy satellites are poised to become even more powerful. We can expect even higher resolutions, improved data processing capabilities, and the potential for new types of sensors that can gather even more comprehensive intelligence. This raises crucial questions about privacy and international relations. With such powerful tools at their disposal, will countries become even more adept at spying on each other? Moreover, can the government use these tools to snoop the public or opposition leaders? The possibilities are enormous. The future of spy satellites is shrouded in a veil of secrecy, but one thing is certain: these silent observers in the sky will continue to play a significant role in shaping the world stage.